All right, we're live. Hopefully everyone can hear me, but let me know if not. So today we're going to talk through the solutions to the problems from Codeforces Round 919. Wasn't my best contest personally due to a couple of things, but mostly misreading E for a little bit, and then I didn't have time to finish F. F1 I knew how to do and could have implemented pretty quickly, but I wanted to just go to F2, and then I had an idea for this one, but code was pretty long and I didn't have time to finish typing by the end. So we'll go over solutions to A through E. Apparently there have been some hacks on D, so yeah, possible there will be some weird stuff going on there, but I think my general idea should work. And then I'll go through an idea for F1 and then a possible idea for F2. Not 100% sure if it'll run in time, but should be at least the starting point. Okay, and then afterwards, just for fun, I'll do a short gaming stream just to change things up a little, and because I have a game that's very little known that I want to show off because more people should play it. Okay, we can start with problem A. So we have n constraints on an integer k, each of which says that k has to be greater than or equal to, less than or equal to, or not equal to some x. And we have to count the integers that satisfy all n constraints. We're guaranteed that there exists at least one constraint of each of the first two types. So that way, so that way we know the answer will be finite. Okay. So the first thing to know is that only the largest constraint of type 1 and the smallest constraint of type 2 will actually matter, because, for example, if an integer has to be greater than 1 and also greater than 2, it's equivalent to just say it has to be greater than 2. So let's just drop all the constraints of type 1 and 2 other than those most significant ones. And let's say low is less than or equal to x is less than or equal to high. Or, sorry, this should be k. Low is less than or equal to k is less than or equal to high. And so now we know that, so first of all, if low is greater than high, then of course there can be no solutions. Otherwise, if not for the constraints of type 3, there would be high minus low plus 1. And from there, so that's a starting point, but then we need to subtract out the values of k that violate the constraints of type 3, which we can do just by iterating over each of these constraints, checking if that value of k is between low and high, and subtracting it from the answer if so. And so I can show you the code to do this. This set is going to store the type 3 constraints. And so then we're just going to set low to be the max of the type 1 constraints, high to be the min of the type 2 constraints. And we'll iterate over all of the type 3 constraints and decrement the answer if necessary. Okay, let's see, I'll answer some questions in the chat. Ortho says, which game? That will be a surprise. Stick around to the end to find out. Amin asks, can I give you my solution for B and you tell me what's wrong with it? In the interest of time, and because I'm sure that a lot of other people are also wondering where the solutions went wrong, I'm not going to be able to go through specific solutions, but if you put a link in the chat, then other viewers might be able to help you out. And otherwise, I'm about to go through the solution to B, and potentially you can find the difference there. Garage asks if my logo is based on the Monopoly guy. Yep, it is. A couple of people saying hello. Good to see you, Naveen. All right, so let's move on to problem B. Alice and Bob are playing a game on an array. Alice is going to remove at most k elements from the array, and then Bob will multiply at most x elements of the array by -1. And Alice wants to maximize the sum of the elements of the array, and Bob wants to minimize it. We need to find the sum of the elements after they finish. Okay. So I think the strategy for Bob is easier to analyze than the strategy for Alice. Since Alice since all the elements of the array are initially positive and Bob wants to minimize the sum of the elements, Bob will multiply the x largest elements of the array by -1. So that's what Bob's going to do no matter what Alice does. Alice then wants to remove up to k elements from the array in order to minimize in order to maximize the result we get after applying Bob's strategy. So the key observation is that Alice should remove the x large, or we already used x as a variable, the m largest elements of the array for some m. And the way we can show this, I'm going to work through the proof fairly informally, but you can fill in the details without too much trouble. But the general idea is, first of all, Alice never wants to remove some element that Bob, or Alice, I should say, can never increase the answer by removing an element Bob doesn't multiply by -1. Because if she removes an element Bob doesn't multiply by -1, then the answer will just decrease by the amount she removed. And if Alice removes an element Bob does multiply by -1, call this element, I'll call it C. Bob will then multiply, so then the answer increases by C because we no longer have a -C in the answer. But now Bob can multiply one more element of the array by -1, but decrease. So the answer will then decrease by twice the largest remaining positive element in the array. And so to illustrate, if we look at the first sample case, 4, 3, 2, 1, or not, the second sample case, sorry. Initially, Bob is going to multiply the 4 by -1, but if Alice was to delete the 4, this would go away, and so the answer would increase by 4. But then the 3 would become negative, because Bob can now put a negative sign on it, and so that's going to decrease our answer because the 3 is going to become a -3. So the answer decreases by double 3. And so given this, given that given that Alice's operation can't control what the largest remaining positive element in the array is, all she can do is try to increase the answer by the largest amount possible, which means removing the largest number from the array. And so that there's a bit of a subtle point here, and that technically this proof only shows that for the first operator, that the best thing to do is to remove the largest element in a greedy sense. So in other words, in one operation, removing the largest element is going to increase Alice's score the most out of any removal operation she could do. But it's not going, but it doesn't prove that there isn't some subtle strategy she could use where she does some deletions that aren't the largest element, and they combine to give a better result than deleting the largest element would. And so anyway, so that's where there's some details to fill in, but proving it formally can be done with a little bit more time. Okay. That said, it's not obvious what or how many of the largest elements Alice should remove, and so what we're going to do is we're just going to iterate over all of them. So, so k times we're going to remove the largest element, turn the largest positive element into a negative number, and we're going to take the best result out of all of these options. So let's see, I'll show you the code real quick. So what I'm going to do, just to make this a little easier to code up, is I'm going to sort the array in descending order. And so initially, the first x elements are going to count as negatives, and the rest are going to be positive. And I'm going to have this variable best to store the best possible answer out of all the options we have. And then for each of the first k elements, I'm going to add the ith element to our answer, and then if there are the next element, which we can do a bit of math to compute as element I plus x, that Bob is going to turn negative if that element is less than index n. So if there's actually another element that Bob can turn negative in the array, then we're going to subtract twice its value from our current answer, and then we'll set our best answer to be the maximum of its current value in our answer. Okay, there are a couple of people who are asking about help debugging their problem. So what I would suggest doing, and I'm not sure if they've made it possible to view others' code yet, but I would say just go to submit or your submissions and just put a link to your code in the chat. Let me see if you can actually view other people's code. Yeah, I think now you can view code without being logged in. All right. Divyansh asks, can you guess the problem rating of B? Hard to say. I don't have a great sense for how problem ratings behave at this level. Let's see if... I think C-list will either have the rating now or if not now, soon. Okay, yeah, C-list... Oh, this is... Okay, it doesn't have ratings yet. Yeah, so other than like look at, you can compare it to past Div 2Bs, I don't have a great sense of this problem's difficulty. All right, let's do C. So Alan has an array A1 through AN. For every positive integer k that's a divisor of n, we're going to partition the array into n over k disjoint subarrays of length k, and we're going to score a point if there exists some m greater than or equal to 2, such that if we replace every element in the array with its remainder modulo m, all of the subarrays will be identical. And we want to help Alan find the number of points he will earn. Okay. So one thing to note is that for a given k to work, we need there must exist some m such that a1 equals ak plus 1 equals all the way up to a n minus k plus 1 mod m. Whoops, mod bracket. A2, it has to be equal to a k plus 2, has to be equal to a n minus k plus 2 mod m, and so on. So let's just figure out for what value of m does one of these conditions hold. So the first thing to note is that for ai to equal aj mod m, this means ai minus aj has to be equal to 0 mod m. So let's fix, just to like make sure we're doing, or just to stick with positive integer arithmetic, let's fix x to be the minimum of a1, a k plus 1, all the way up to a n minus k plus 1. Then for all I in 1, k plus 1 up to n minus k plus 1, ai minus x has to be equal to 0 mod m, meaning m is a factor of the GCD of all ai minus x values. So this proves that being a factor of all these numbers is a necessary condition, but the question is it sufficient? And it's pretty easy to prove that this is also sufficient, because if m is a factor of all of these, then that means that whatever x mod m is, ai will also be equal to that mod m for all of these I. And that means that all of these numbers have the same value mod m. And so that means that we can just check if the GCD of all of these values is greater than 1, and we also have to work in a special case for if some of the AIs could be equal to x. So what we can do is for a given k, we can just find x for each of these ranges, find this GCD, and then we can and then we can check if that GCD is greater than 1. The one thing to do is to make sure is this is going to run in O of n for each value of k we want to check. But we want to make sure there won't be that many k. And so the number of values of k is equal to the number of divisors of n, and so the complexity is n times num divisors of n. And we want to make sure that'll be fast enough. And there are a couple of ways you can do this. One is to use the approximation that the number of divisors or the maximum possible number of divisors of any number less than or equal to n is about the cube root of n. So that's an approximation you can use, and otherwise you can use look up a highly composite numbers list, which is a list of which this gives like each number that has more divisors than any smaller number, and I'll link this for you. And you can see that the largest one, less than 100,000, has 128 divisors, and that means the end time, and so 100,000, or wait, no, I guess the limit is 200,000, but should be basically the same result. 200,000 times we can have up to 160 divisors. That's going to be 2 times 10 to the 5 times 160. And dividing by 10 to the 8 gives it this should run in about 0.32 seconds, which will easily pass the time limit. All right. And I guess the other thing is that there's some complexity associated with the GCD. So I guess we have a log n factor here, but even then, 0.32 seconds times. And so I guess if you factor in the log factor for GCD, then it can seem like it's going to TLE. But the trick is that taking the GCD of a series of n numbers requires, I want to say like n plus is actually n plus log n time rather than n log n time. And I would encourage you to try to prove this if you're interested. But in any case, the GCD constant factor is really good in general, so this ends up working fine. So let's look at the code real quick. So what I'm going to do is I actually abuse notational, I use m to refer to k. But for each value of k, excluding the ones that aren't divisors, I iterate over each like position in our subarray. And then now, for each subarray, I take load to be the minimum value among like our first element of each subarray, our second element of each subarray, or whatever. And then I take this lowest one, and then I take our current value to be the GCD of itself and our value minus low. And then to deal with the fact that there can be zeros in here, I have like a safe GCD function that does a little bit of special casework, where if if one of the numbers is 0, it just returns the other. 0 just means like 0 I just take to mean like the number that's divisible by everything. And then otherwise I just return the GCD of x and y. And then if our answer is not equal to 1, then we can use, or if our GCD is not equal to 1, then then our score increases by 1. Yeah, so a couple of people are saying they thought this approach would give TLE. So bookmarking the list of highly composite numbers is definitely useful. And then I think the other trick is just knowing that taking the GCD of a series of numbers is very efficient. All right, let's look at problem D, array repetition. We have an array A. Initially, it's going to be empty. And we have n operations of 2 types. The first is just appending an integer to the end of the array. And the second is appending x copies of the array to the end of the array. So so for each query, we have to determine the kth element of the array A. Let's see, before someone has a question about, like, do you have any general framework for how to approach and solve the problem? I guess basically what I would say is that once you know that like there are few enough divisors of each number that we can check each array or each value of k individually, then like that the problem is just about like determining whether there exists a value of m such that like all of these arrays are the same. And then from there, it can often be helpful to look at the slightly easier problem of checking whether a1, ak plus 1, and an minus k plus 1 are all the same modulo m. And from there, if you just write out the modular congruences, like a1 equals ak plus 1, ak plus 1 equals a2k plus 1, like, and so on, then you can like, for some people, this idea that like m has to be a divisor of like a1 minus, or of ai minus aj for any I and j would be pretty standard. But if you haven't seen it before, then if you write out the equations and manipulate them a bit, then it'll help a little bit. Apisha asks, these primes in problem C. No, I don't have any special like casework to deal with primes. Okay, so problem D, we're gonna either append an integer or just append a bunch of copies of the array to itself. We have q queries, and for each query, we have to determine the kth element of the array. All right. One quick observation that's pretty helpful for problems like this is that every time we do an operation of type 2, the array size at least doubles. That means after 60 operations of type 2, the array will have size at least 2 to the 60, which is greater than 10 to the 18, which is greater than k for any query k. Okay. So that means there can only be up to, or that anything that happens after 60 operations of type 2 won't affect our queries because we've already had or gotten 10 to the 8 elements. So now let's think about like a slightly inefficient solution. So if we do an O of NQ solution, what we're going to do is we're going to work backwards. So iterate through the operations in reverse order. If the last operation is to append an integer, then if k is equal to the length of the array, the answer is the number that just got appended. Otherwise, just the length of the array decreases by 1. And if the last operation is to copy the array, the idea is that say the old length of the array is L. So the idea is that k or the kth element of the new array is the k mod L element of the old array. Because the idea is that, so if k is like 1 through L, then it'll just be like the kth element. If it's like L plus 1 through 2L, then like the L plus first element of the new array is the first element of the old array, and so on. Okay, so we can work backward, or we can work backwards, and simulating this directly would be O of NQ. But it's not super hard to to make this more efficient, and there are a couple of ways you can do this. I ended up just for ease of implementation doing a slightly simpler like Q log squared n solution, but there's also a way to do this in Q log n. So the way we can do this is, let's figure out for each operation, let's for each operation, let's find the length of the array after this operation. So the idea is that so we're going to binary search for the first operation, after which the length of the array is greater than k. And the motivation for doing this is that if the length of the array, or in our backtracking approach, if the length of the array before an operation is greater than k, then we do nothing for that operation, because if it's an append operation, then we don't do anything. We just decrease the length of the array by 1. And if it's an array copy operation, then if the length of the array before that copy operation is larger than k, then k mod that length is just k, so we don't do anything there either. I see there are a couple of questions about C. I'll go back to that once I finish going through D. So so then if this, so once we do this binary search, if this operation is I guess I should say greater than or equal to k. If this operation is an append operation, that gives the answer. Otherwise, take k mod the prior length. So from there, and Adam says, now I start to worry about FST because I didn't use binary search. Don't worry, there are other valid approaches to use for this problem. And I might go over one of them in a moment. So, okay. And so in terms of the complexity, each binary search is O of log n. And the number of binary searches we're going to need to do is the number of like modulo operations is less than, or is at most 60, is at most like log k here for the same reason I outlined here. And so that means that our complexity is q log n log k, which might be a little bit slow, but in the context of a 4-second time limit, that's going to be about 10 to the 5 times 18 times 60 divided by 10 to the 8. That's going to take about 1.08 seconds. And given that the constant factor for binary search is really good, it actually should be even faster. Like, let me see if they have an editorial out already. I'm curious if they, yeah, looks like they have two different solutions. So the way 2 is what I'm describing here. But anyway, in my case, it goes faster than you would expect. Just takes 200 milliseconds. I'm curious what their complexity is for. Okay, looks like they have a better complexity than I did for F2, so that's interesting. All right. Yeah, so that's one approach. The other thing you can do is you can do the same backtracking approach, but just combine all append operations into one, combine all append operations between every copy operation into a single operation. And so what I mean is that we would say like the operations might be like append 3 elements, copy 2 times, append 5 elements, copy 4 times, and so on. So now there are only O of log k operations to backtrack through, and then once we find the append operation that adds once we find the append operation that adds our kth element, we can just find or we can use k as the index in the array to find which particular operation worked. Okay, so let's go through the code. All right, so we're going to read in the operations, and we're going to find the number of operations after each approach. And so if it's an append operation, the number of operations increases by 1. Otherwise, we multiply by the number of copies plus 1. I have to write like a safe multiplication function to make sure that we don't get long overflow. So what I do is if the sum of the logs of the numbers is greater than 18.5, which is shorthand for xy is greater than 10 to the 18.5, then I just set it to 2 times 10 to the 18, which is larger than any of the values in the problem anyway. And otherwise, I just return x times y. And here I do this. I basically drop all the operations where until the operation before the last is less than 10 to the 18. I don't think this actually mattered for anything. I was just doing it as part of my debugging process. For each query, I read in the value, and then until I found the result, so while true, I binary search for the first operation, after which we have k values. If it's a type 1 operation, I just output the value, and otherwise I divide by the prior length. All right, great. So let's see. A couple of questions. I mean, is it normal that I only solved A when I'm in Division 4? No, that's pretty standard. B can be tricky when you're getting started. Let's see. No one says if K is prime in the subarrays, would satisfy the given condition, then all factors of K, which are also divisors of N, will work. Is this approach correct? I don't. Well, if K is prime, the only factor of K, the only factor of K other than K itself, should be 1. In any case, like you don't really need to do any special casework based on whether things are prime. Let's see. Chandu asks, can you show how you read and take key ideas from editorials and how I look at formulas in editorials? So let's see. I think first of all, I talk about this a little bit more in my AMA, so I'll give you a link to that, and reading that might be more helpful. Where is this? Scroll down. Oh, no one says all multiples of k. Yeah, that's correct, but that claim doesn't require k to be prime. Because if a1 through ak plus 1 through a2k, a2k plus 1 through a3k, and a3k plus 1 to a4k are all the same, then that means a1 through a2k and a2k plus 1 through a4k, for example, will also be the same. Because here we're just comparing a1 and a2k plus 1, which we already know to be equal, a2 through a2k plus 2, which we already know to be equal, and so on. Okay, and so, but in terms of reading editorials, so I think first of all it's important, or what I usually like to do is work on a problem myself, and then if I get stuck, I'll look at the editorial and I'll just read as far as I need to in order to get, I'll just read as far as I need to in order to like find the first idea that I haven't come up with yet, and I'll try and continue to solve the problem on my own. So like one thing I would say is if you're at the point where you're struggling to, or where like even after attempting for a long time, you're unable to understand the editorial, I would say that the problem might be like too hard for you right now, and you should put it aside and work on it again later on. Other than that, like I don't think I have any particular secrets to like understanding formulas and editorials. I think it's just a matter of having a sufficient math background, and then just spending time working through all of the calculations. Other than that, there have been a couple of questions about learning number theory about math in general. So I write some stuff about this here. I think for number theory specifically, the resource I initially started with was Introduction to Number Theory, which is a book by The Art of Problem Solving. I think that it's linked on this post. And I also have like advice on one way to get better at number theory in this blog. There might be other better ways, but in general, like I found training on number theory and combinatorics math contest problems to be a helpful background for getting started with programming contests. Okay, Guraj asks, can you tell what is my profession or where do I work? I currently am an economics researcher, and but starting in May, I'm going to become a quantitative trader. Apish asks, does AOPS cover most of high school math? Yeah, AOPS covers basically all of the high school math, or all of like the high school math contest topics. For competitive programming, you don't need quite as much algebra as AOPS covers, and you really don't need any of the geometry for the most part. But the combinatorics and number theory that come up on high school math contests are super important for competitive programming. Laconic says, you also did Alchemist for math? Yeah, I did. I also used some other tools, such as like the AOPS books or practice contests for like the AMC 10 and 12 and the Amy. But Alchemist is one resource, and I think that it's a great one to start with if you're beginning. Okay. All right. Luke, I understand that you're disappointed, but you're just going to have to deal with that. Okay, let's move on to problem E. This was a nice one, but it took me way too long because I accidentally solved a significantly harder problem. I solved a somewhat harder problem and then spent a ton of time debugging it, and then once I realized the correct interpretation, I was able to solve this in like 5 minutes. Okay, we want to count the number of binary strings S, such that S contains exactly n good substrings and has no good substring of length greater than k. And a good substring is a substring that contains exactly 1. So a lot of the time, whenever we want to count the number of binary strings that contain n good substrings, it can be helpful to solve sort of the reverse problem where we want to just check if a binary string contains n good substrings, or even just like figure out how we count the number of good substrings in a string. So what we'll do is for each one in a string, we'll count how many good substrings it contributes. So if that one has x zeros to the left before the next one, and y zeros to the right, before the next one. So now, so for example, in the string like 0, 0, 1, 0, 0, 0, 0, 1, then for this one here, x would be 2 and y would be 4. So for a good substring, the left endpoint can be any, or we can have x plus 1 options. We can be, because we can do right before the 1 or before any of these x zeros. And then likewise for the right endpoint, we can have any of y plus 1 options. And so this one contributes x plus 1 times y plus 1 good substrings. And the maximum possible length, which would include any of these zeros, is x plus 1, x plus y plus 1. Okay, so now we need to count the numbers where this ends up equaling n. So we're going to end up using dynamic programming. And so our DP state is going to include two things. So first is I is going to be the number of good substrings so far, but then the other thing is we have this like y value, and the y for the number of zeros after 1, 1 is also going to be the number of zeros before the next one. So we also need to keep track of the number of zeros after the last one. All right. So with this, now with this in mind, for our transition, we're going to iterate over the number of zeros after the next one. So the new number of goods, so the second dimension of the new DP is easy to compute. Let's call this k. No, we already have k. The number z, let's say. So we know that the next value of the second DP dimension is going to be z. But the next value of the first DP state is going to be I plus the number of good substrings corresponding to this one, and that's going to be the number of zeros that we got from the prior one times the z plus 1 value. And so this is going to get DP of I of j. All right. So let's see, is there anything else I need? I guess the other thing I should say is that because we need to make sure that x plus y plus 1 is at most k, that translates to g plus z, or j plus z has to be less than k. So this, at first glance, this looks like n squared, or an O of n cubed algorithm, because we have n squared or DP states and O of, like, I guess maybe n squared k. Or I guess nk squared, because I can be up to n, j can be up to k, and then z can also be up to k. But it turns out that this is actually just O of nk log k. And this is a pretty well-known fact that's worth learning if you haven't seen it before. But the idea is that the number, or so for a given I, the number of pairs j and z, such that, I guess it should be nk log n, such that j times z is less than or is at most n. And it has to be for it to be a valid transition, because I plus j plus 1 times z plus 1 has to be at most n, is O of n log n. So this means in general that any loop of the form for I from 1 to n, for j from 1 to n divided by I, these nested loops are always O of n log n. There's a nice proof. I think there's a Codeforces blog about it, although I don't have the link on hand. But because of that, the number of choices of j and z for each value of n is going to just be O of n log n. So this algorithm is just going to be, for O of n values of I, we're going to have O of n log n choices for j and z, which gives us an O of n squared log n complexity overall, which is going to be fast enough. So I'll show you the code. The code turns out to be really simple if you ignore the commented out stuff from my previous incorrect approach. So it might, for my base case, we can have 0 good substrings and then any arbitrary number of zeros at the beginning. And then for each I, j, and k here, I just implement the transitions exactly as I wrote them here. And then I make sure to break as soon as our next state is greater than n. And then I add, and then I just update the DP table, and then at the end I output the sum of all of the DPs corresponding to n good substrings. Indie Gaming asks, can you share a recursive approach to solve problem E? I mean, this DP can be pretty directly translated into a recursive solution. I would say though that in general, using a DP table will be substantially shorter. It will be it'll involve shorter code, and it'll have a faster runtime than a recursive approach. So I would say you can basically type the same solution recursively, but I think this is probably the better way to go about it. Okay, let's move on to problem F. So F1, I knew how to do. I just decided not to implement it to try and solve F2. So the statement's a little bit long. So we have 3 types of cells. We have an island, an ocean, and an underwater volcano. And we're going to define a round trip as a path that starts and ends at some position x, y. And we can go in the 4 directions. And the path has to fully encircle the island, meaning that we shouldn't be able to start at some cell on the island and get to the border of the grid by going up, down, left, right, or diagonally without crossing our path. So for example, this example doesn't fully encircle the island because we can go from here to here to here and then diagonally like this. Okay. And then the key idea is that in a round trip, we can visit the same cell multiple times. The safety of a round trip is the minimum Manhattan distance from a cell on the round trip to an underwater volcano, and the volcanoes are just certain cells that are given to us in the input. And we have to figure out for each of Q queries, we want to find the minimum possible distance. We want to find the minimum possible, the maximum possible safety. So for example, this path is a round trip that blocks off the island from the border and has safety 3 because the shortest distance from a volcano to our path is 1, 2, 3. All right, so for F1, we only have 5 queries, which makes this significantly easier. So we're just going to solve each query individually in O of nm log or nm time. So what we're going to do is we're going to binary search for the answer. So for a given query, so we want to check if a path with safety S exists. If a valid path starting and ending at x, y with safety S exists. So the first thing we're going to do is we're going to use a BFS or DFS to determine the distance from each cell to a volcano. And because in order to have safety S, we can't travel through any path or through any vertex with distance less than S to a volcano. In order to, now what we're going to do is we're going to find among the vertices we can travel through, we're going to find the connected component containing x, y. And it turns out we can just do using a BFS or similar, we can construct a round trip visiting every vertex in this connected component. So now we just need to check if this connected component blocks off the island from the border. And to do this check, we can just do a BFS starting from the island, and or such that we aren't allowed to go through any of the vertices in our connected component. And if this BFS can reach the border, then we can't achieve a safety of S. But if we have successfully blocked off the island from the border, then we can achieve safety S. And so thus, like, using binary search, we can find the maximum possible S for which a path exists. So that's the solution here, or set for F1. F2 is significantly harder. I had an idea that runs in n square root of n log n, but with a very good constant factor. But I think maybe I'll go through the editorial solution, which seems to be more efficient rather than talking through what I did. So let's see. Oh, this is an interesting idea. They're going to consider the path or the point and polygon test. Okay, interesting. So it looks like they're going to view the path as a polygon, and in order to enclose the island, let's see. An imaginary line along the top border of the cell. I see. Okay, so that so for each vertex in the island, we should be able to draw a line like extending to the right, and it should cross our round trip once. Okay, let's see. And so then they're going to define their state as, and I'm going to see, like, did they just do the binary search? Yeah, it looks like they just did the same thing that I did for F1. All right, and so then what they're going to do is they're going to add states one at a time in decreasing order of their distance to a volcano. And so for each query, we just want to find the first time when we can get from that point with an even number, starting from 0 times crossing the line, and then we can do a round trip and get back to that point with an odd number of times crossing the line. And so checking like the first time when two vertices become connected can be done using a DSU with small to large using small to large merging, or there are a couple of other approaches. Let's see. So anything else I need to say about it? And so like the way we can do that, by the way, is we can build the DSU tree and find the LCA of the two vertices, and that LCA will tell us at which query the two vertices get merged. And what I mean by the DSU tree is, so for the DSU tree, each vertex is initially its own, or each, I guess, vertex in the original graph corresponds to a leaf in the DSU tree. And for each merge, we construct a new vertex whose children are the two vertices that were merged. Okay. Cool. And it looks like this is like the nm log nm plus q log nm solution using LCA on the Kruskal's reconstruction tree. But I think you can maybe do it with small to large merging in your DSU, and that might make it a little bit simpler. Okay, cool. Let's see. All right, so that's our solution. Anything else I want to say about the contest? Nope. Okay, we're good to go. If there are any other questions that people have about the contest, I'm happy to answer them. But otherwise, we will transition to a short gaming stream. So yeah, a lot of Deadpool. I'm about to explain that. So there have been a lot of big name games that have come out: Baldur's Gate 3, Tears of the Kingdom, etc. My favorite game of 2023 is probably not one that you have heard of, and it is called Grid Game. And I'm going to put a link in the chat. Okay, so this is a puzzle game where you press space and then you're shown a grid, and you have to construct a path from the left side of the grid to the right side using the arrow keys. But it's not as easy as that. You can see that even though I've gone from the left to the right, I haven't won. And the trick is these symbols that are all about the, or that are all around the grid. They each have different rules associated with them. So for these little cycles, you have to cross over one of the edges adjacent to them, but you can't go around them in the wrong direction, meaning I can't go up here because the cycle is going down. Now for these diamonds, what the diamonds mean is that you have to reach them and then turn. So I can't go straight, but I can go through them and then turn around. The squares are the opposite of the diamonds. You have to go through the squares and then just keep going in the same direction. You can't turn around at a square. So I can't do like, here, I'll start again. So at a square, I can't do like this, for example. And the last are the little ones with the bars in them. These might be numbers depending on your browser. So for these, you have to go around exactly the right number of edges around them. So for this one, I have to go through one edge around it, but then I can't go through any more. And then for this one, it has a 2 on it. That means I have to go through 2 and I can't do any more. Okay, and so the goal is to find a path through that satisfies all of these constraints. This is a pretty difficult game when you're getting started. If you win like around anywhere from at least like 30 to 50% of the time when you're first trying it, you're doing great. But it's possible to practice this and start getting really fast. And for some reason, I found this fun in like largely the same way as competitive programming, where I felt like I was just building new intuition for how these paths work. So like a simple thing that you would notice, for example, is that for any of the only way to go around these 3 paths is to make like a little U shape. And so by noticing patterns like that, it turns out that you can improve quite a bit. And so I went from winning about 40% of my games when I first started to now I have about 5,000 games on my laptop. But on this PC, I have 560 games, of which I've won 97% with an average time of 13 seconds. My best time ever for finishing one of these was a bit under 3 seconds, and I'm pretty sure that 2 seconds is more or less impossible. Okay, and so this is what it looks like when, oh, hold on, I'm going a little bit more all out. Okay, back to this. Nice. Garage asks, what other games do I play? I don't play chess. Let's see, what else do I play? I play like some FPS games I've currently been pretty into, the finals. Let's see, I've been playing random battles on Pokemon Showdown recently. I think those, I guess, let's see, there's some, I feel like I've played a fair amount of Valorant for the last few years. Yeah, a couple of things like that. Okay, hold on, I think I got it. It's a little bit of a trickier one. Yeah, I'm not sure what to do with this. Okay, I don't think this is going to work. Okay, nice. There's a cool shortcut where you can hold X and it'll retrace the path that you previously stepped. So if you need to go back and change something at the beginning, you can use that. SCR asks if I play League of Legends. Nope. Every now and again I try it again, and every time I do, I'm quickly reminded of why I uninstall League of Legends. Time to ask, don't I just want to play games all day rather than solving problems? No, I mean solving problems is fun, and ultimately, like, Codeforces sort of gets to the competitive urge I have, and I think that the aspect of like trying to become better and get the highest ranking I can at Codeforces motivates me to continue practicing as well. It's just the fact that it's fun. Rosvan asks, can I show my stream library? My Steam library. No, I'm not going to do that. Mostly just because I don't, partly just because I don't want to dox my Steam, and partly because I endorse a very limited fraction of my Steam library, because probably like 70% of it just comes from random bundles that I've never actually like, that I might have like bought for one game and then never actually used the others. So it's a bit of a random mix. Okay. Yeah. So this is like mostly all that I have. I'll stick around here for a couple of more minutes just in case anyone has remaining questions. But the contest explanations part of the stream is pretty much over. So thanks everyone for joining. Jerry asks, have I tried Counter-Strike? Yeah, I think I like Valorant better, just because less emphasis on like on really obscure mechanics, but it can be fun, and I play it occasionally when when I have friends who are playing who don't have Valorant installed. Rosman asked if I like Sudoku. Occasionally, like, out of that like style of games, and I find like doing Picross puzzles really relaxing, even though they usually aren't super difficult. Guraj asks, which ID do I use for Codeforces? I use Vim. There's a video called, let me find this, I can link it for you, My Competitive Programming Setup. And I've linked right there, that goes into a little more about like how I've set it up how I've set up my Vim configuration. Ultimately, though, I don't think it matters that much which ID you use. I would just use whatever you're going to be comfortable with. Okay, oh, there we go. That's a weird situation. Oh, we can get a good time here. Nice, 4 seconds. Rosvan asks if I know my words per minute. You know what? Let's find out. I know like on a good day and on a sufficiently short text, like I can get up to 150, but my actual time significantly varies. Indie Gaming asks, how can someone learn Python for competitive programming? I don't have a great sense of what the good Python resources are, but I would say if your end goal is to do competitive programming, then Python probably isn't the best language, since many problems are not designed to be solvable using Python. Avenue asks, after Introduction to Number Theory from AOPS, what book should I read next, or what should I do? I mean, I think that'll give you sufficient background to just start solving problems, and I would say from there, like you can look up more outside resources if you find like you're often reading editorials and unfamiliar with the background they require. But I do think that after you have like that foundation in the basics of modular arithmetic and stuff, then you can start picking up ideas just from the editorials. Only number theory is enough from AOPS. I mean, I guess enough for, it's sort of like enough for what? Like, it depends on what you're trying to accomplish. I think like counting of probability books would also be useful, but you also can do well while buying no books if you, and like an alternative, for example, would be solving number theory and counting of probability practice problems on Alchemist. Oh, maybe for strict math rather than for competitive programming. If you want to learn more number theory specifically, let's see, I think there's another book that AOPS links somewhere. Where is this? I'm trying to remember what this is called. Oh, this is it, I think. Yeah, here's like a more advanced number theory book if you're just focused on that. In general, like I think all of the other AOPS books I found very useful while I was preparing for a math contest back in high school. Light Yellow asks, where did I study competitive programming fundamentals? Back when I was I'm not sure this is like the right way to go about it, but back when I was getting started, I used Competitive Programming 3, which they have a new edition actually, but you can find at cpbook.net. I think there are some things that I don't like about this book. So for an example is that I think the chapters are ordered by topic and not by difficulty, and that means that there are some. I'm trying to find where's the table of contents listed. So I think that'll be helpful to show you. Not sure. Well, anyway, so maybe it's here. Nope. Okay. Well, anyway, so for example, the second chapter of the book is about data structures, and a lot of the here we go. Yeah, so chapter 2 is data structures, and there's a lot of stuff about Fenwick tree and segment tree that I think are significantly more difficult than a lot of the later topics. But I will say that coming from a math contest background, chapter 3 was very useful to me just because it sort of showed me what are some of the key ideas that I should be thinking about in solving programming contest problems. Yeah. In terms of alternatives, though, I think the Competitive Programmer's Handbook, book.pdf, I think will get me there. Yeah, here we go. Yeah, so the Competitive Programmer's Handbook, which I'll link before, is a free resource that a lot of people like. I think the main downside of this book is that it doesn't do a great job of showing how you can apply the ideas that it teaches to actual competitive programming problems. And so you would need to supplement this with regular practice, but it can be a good resource for learning some of the fundamentals. Someone asked, I've been doing competitive programming for the past 3 years. What should I do to improve? I think I guess I've said most of what I've thought about in terms of how to improve on my AMA, which I linked above. I think really it just comes down to practicing problems and then and then when you can't solve them, focusing on reading editorials and implementing your solutions in a way that maximizes how much you take away from the problem. So actually, I can give you a good example. So if we look at problem F from today, F2 I wasn't able to solve in time. Then when I look at the editorial, I would think to myself, okay, what's the first step of this problem that I didn't come up with? And the first step is realizing that we can sort of use this point and polygon trick. And so what I would try to do is I would try and condense that into a lesson that I can apply that I can apply to a much broader range of problems. And so a simple version of that would be even in a graph problem, if I want to check if one object is contained in another, I can use the standard point and polygon test. That would give me this idea to try. But even the other thing I could do is the even more general version of that is that even when I'm looking at a more abstract object like a graph, if I want to look at or if I want to analyze geometric properties of some configuration, then I should start thinking about algorithms from geometry in order to do that. And so here, the idea would be fundamentally, the island's containment in this path is a geometric property, and so we can use the geometry algorithm of point and polygon to assess or to determine whether we've achieved containment, and that idea would have been enough to get me to solve the problem. And so that's basically what it comes down to, is taking away concrete lessons from problems you can't solve and you applying them to very distinctive, or applying them to problems even when the new problem doesn't look much like the old one. And another example of this is, let me find this. I like how it shows results for the correct spelling of Odyssey, but actually Odyssey is misspelled in the problem title. But anyway, so this is a Codeforces problem that I failed to solve a couple of years ago, and the correct solution is basically, and I won't go through the whole problem, but the general idea is basically to show that that if you have an incoming and outgoing edge of the same weight at a vertex, you can just replace them both with a new or with a separate. So if we have here, let me write this down. If we have edges A to B and B to C of the same weight, then it turns out we can show that we can replace them with a new edge A to C of of the same weight, and that reduces the number of edges. And so anyway, if you apply this reduction a bunch of times, then you can show, then what will happen, or then after you can't apply this reduction anymore, any vertex will have at most one edge of each weight. And it turns out that this gives you a new constraint on the input that makes the problem much easier to solve. When you know that this is true, the problem turns out to become pretty easy. Anyway, so that was the idea that I was missing. And so what I took away from this is basically, if there's a way that we can simplify, if there's a trivial way to simplify the input, then I should do that, and that'll give me a new constraint on the input that might make the problem easier to solve. And I turned out to use the same, and so that's a very, very general idea that's applicable to problems that don't look at all like this. And so another example is this problem, hoof and brain from Yusuko, which is a pretty hard problem, but I strongly recommend it. I thought it was one of my favorites. And for this problem, you'll find that this ends up, or that this is sort of a game theory problem where it doesn't superficially look anything like the other problem. But it turns out that in this problem, we can also simplify the graph by basically taking out, for example, any vertices with no outgoing edges, or any vertices, or any vertices with exactly one outgoing edge. And when you do that, you can get the additional constraint such that every vertex has multiple outgoing edges. And when you have that constraint, this problem becomes much easier. And so I was able to solve it using the same idea. And so that's an example of how I was able to take away a concrete lesson from a problem I failed to solve, and then apply it to solve a very different problem in the future. And that's pretty much that's pretty much, I think, the key to improving at competitive programming. And I should say, even though the examples I'm using are for pretty difficult problems, you can definitely apply the same logic to even simpler problems at the Division 2 level. So this is not just a way of improving that only works for top competitive programmers. So that was a good time. Let's see, what am I doing here? There we go. Guraj asks, why is my name geothermal? Well, back when I was, I would have been 14 at the time, they started letting people change their usernames on Minecraft, and there's a challenge because most of the really good usernames were quickly snapped up, and so I wanted to use a name that sounded pretty cool, and that was interesting to me, and that was actually available on Minecraft. And I was studying geothermal energy in school at the time, thought it was pretty cool, saw that it was an available username, and ended up taking it, and I've used it for pretty much everything ever since. Hold on. Oh, I can fix this. There we go. Nice. How about Dieng? How does that sound? That's pretty good. Nice to see you, David. And the other thing I like about geothermal is that it abbreviates nicely. People call me Geo. Works out easily. The one thing that's a little bit funny is that back in high school and continuing on to the present day, Geo, or geometry, was my worst subject in math and programming contests, while combo or combinatorics has always been my strongest subject. And so I have the nickname Combo Thermal on a couple of Discord servers, and I think I've used it as, you'll use it as an account name occasionally when geothermal is taken. Play Black Myth. What's that? Interesting. New RPG coming out. Looks like It's really not releasing for a while. Can you explain the game you're playing now? Sure. So I did a bit earlier in the stream, but I might have gone a little fast, so I'm happy to go through it again. So the way it works is your goal is to draw a path from the left of the screen to the right. But the catch is, so here, I'll show you, but the catch is that there are all of these different symbols with rules that you have to satisfy. And so an example is, with the squares, you have to pass them and then go straight through. You can't go through a square and then turn at an angle. So if I try and go down here, it won't let me. The diamonds have the opposite rule. So you have to pass through them, but you can't go straight forward. You have to turn. These cycles here, you have to take one of the edges around them, but you can only go in the right direction. So I can't go up here because the cycle is pointing in the opposite direction, but I can go to the right, and you can see that now the cycle is satisfied. And then finally, you have these bars, and there'll be numbers on other web browsers. For these, you have to go around the right number of edges. So you can see the correct path goes around 3 edges of this box. So like here, you can see if I go through 2 edges, then that 2 is satisfied, but it won't let me go through a third. And let me see if I can give you an example of that. So like, for example, now that I've gone through 1 edge here, I can't go to the right because that would be 2 edges of this one. And so you have to draw a path to the end that satisfies all of these different conditions. Oops, okay, hold on. Whoops. Anyway, it's a very difficult game when you're starting out. I think if you're playing for the first time, then winning around 30 to 50% of your games is great. But if you grind hard, I have about like 5,000 or 6,000 games on my laptop in addition to the 500 ones here. Then you can start winning pretty consistently, and I think the process of improving is really satisfying. Someone asked for the link. I will put this in chat. And to give credit where credit's due, this game was made by Paul Cristiano, who I believe is an AI researcher, and anyway, it was made as a personal project. I think it's inspired by this puzzle game called The Witness, but he posted it on his Facebook, and a couple of friends and I have been playing it ever since. Break the Shell says, I did not show my words per minute. That's true. Let's see how fast I'm typing today. Okay. I think I might be a little slower because I'm not on my main PC, so keyboard I'm a little bit yet less used to. Ooh, okay, this is not going great so far. Okay, so that's 126. I've gotten, or you can, I think, I don't know, it went down a little bit during the time when I was trying to talk while I typed. What is my current keyboard? So right now I'm on a Razer Black Widow, which I think might be the one you're thinking of. It's the one that I used to be the, or it's the one that I used to use as for my main PC. Now, here, I'll link to my brother's review video. But I use a Vissel's LP85 as my main keyboard, and that's nice just because it's very compact and so it doesn't consume much room on my desk. Udoy asks, after 1 year of competitive programming, I'm stuck at gray. Is this normal? So I think it's hard to say it depends a lot on your background. In the sense that, like, I would expect someone coming from competitive programming after, for example, doing math contests for a few years and then continuing to practice competitive programming consistently. I would expect someone in that position to advance past gray faster than in a year. But if you're just getting started, or if you're coming with like not the same prior math background, and if you aren't practicing on a super consistent basis, then it's not like ridiculous to be stuck at gray after a year. So I would say everyone's path is different, and you shouldn't feel too much pressure to get to a certain rating after a certain amount of time. Having said that, if you feel like you're getting stuck on relatively easy problems because you don't have the same math background that they assume, I have some advice on improving at math in this blog post that I'm linking. Gaurav asked, what's the meaning of geothermal? I talked about my username a couple of minutes ago, so you can rewind a bit in the stream to see. The short version is I needed a username on Minecraft. Oops, okay, no, that's not gonna work. Okay, gotta go down first. Yeah, this is better. Leia asked, what's the secret to getting LGM? I guess I would say the process of improving that I discussed earlier, and continually learning from the problems you can't solve. Praveen asks, can I share some starter resources for competitive programming? So I think I think I talked about getting started a little while earlier in the stream, and I have some links to references up there, but I'll put them down again. These are some books that you can use. Usecode.guide, which I'll also link, also has some helpful resources. And then once you're, I think I wouldn't recommend this necessarily to an absolute beginner because most of the articles are a little bit more advanced. But whenever I'm looking up a new algorithm that I don't know, cpalgorithms.com is a good place to learn. Leo asked for my LinkedIn profile. I mean, you can probably find it on Google, but I'm not going to post it because I generally don't add people who I don't personally know, or who I don't know personally, on my LinkedIn. Nope, okay, hold on. Divyansha asks, have you seen Colin, Galen grind? Do you think we need to work that hard to get to higher ranks? No, I mean, I can say there's like never been any time when I've been consistently working 8 to 10 hours a day at programming contests. And I also think that I think this is true. I think like did he change his name? Or was it what, Galen Colin? Probably haven't friended. But anyway, I think if I was in his, or I think I remember looking, and it seemed like he hadn't been competing in Division 1s recently. So I think honestly the main thing I would do if I was him to improve faster is just start competing in every Division 1 contest, partly because there are sufficiently few of them that you'll miss out on a lot of opportunities to improve your rating if you don't compete consistently. And partly because I think that's a good way to get a sense of where your strengths and weaknesses are, as well as to accurately assess your current ability. Georgie asks, how old are you and how many years have you done competitive programming, and have you done any Olympiads? I'm currently 23. I've been doing competitive programming for, I started in the fall of 2015, so 8 years now. I had done math contests for 5 years before that. Although since I was in middle school at the time, it wasn't anything super crazy or serious. In terms of Olympiads, I did the USA Computing Olympiad. I was in the Platinum Division in high school. And then ICPC, I wouldn't consider an Olympiad, but as like an on-site event. I have done ICPC, and my team has qualified for the World Finals 3 times. Same asks, what's more appropriate, learning topic-wise or learning by practice? I usually recommend just learning by solving practice problems. And the reason is that if you focus on learning by topics, you might not choose to focus on the topics that are most relevant to you at your current level. The one exception is that if you see a new algorithm while you're practicing that you haven't seen before, I would find and solve a couple more problems about that related topic just to make sure that it makes sense in your head, and then moving on. Garage asks if I'll accept their connection request. Unfortunately, I generally only accept LinkedIn requests from people who I know in real life or otherwise like have a direct connection to, like, you know, going to the same college, for example. Indie Gaming asks, what company am I currently working in? I currently work for the University of Chicago. Garov says, and today's round is my first time becoming specialist. Congratulations, nicely done. Shashidar asks, how to build intuition step by step. So I think I talked about this in more detail a little while back, but I think the key to building intuition is working on a lot of problems, and then when you can't solve a problem, condensing the editorial or the part of the editorial that you didn't come up with yourself into a lesson that you can apply to future problems. Ananya asks, how should I practice ad hoc problem solving? I would just say, I mean, I think I would say the same thing. I don't think there's any particular way of practicing that's magically significantly more efficient than anything else. I think it's what's the most important is just solving a lot of challenging problems and learning from the ones that you can't solve. Carrie asks how to improve at solving greedy problems. Yeah, I mean, pretty much same answer. I would say the same answer. I think with greedy problems, you have to get used to, like, number one, identifying potential greedy strategies, and number two, proving that they're optimal. And both of those, I think you can practice just by working on a lot of problems involving greedy strategies and learning from the solutions for the ones you can't solve. Okay, maybe I'll have to go back to this at the end or something. This is an odd configuration. Oh, maybe can I do this? Yeah, that works. Rosvan asks, why don't you use a Linux OS? WSL does all of, like, the Linux-based stuff that I need, and then I find Linux pretty annoying to use, mostly because I, like, constantly have peripheral compatibility issues. I tried using it for 6 weeks, and it felt like every week I would need to spend several hours debugging, like, why my microphone wasn't working or why my mouse sensitivity suddenly dropped super low or something like that. And then secondly, I sometimes like to play games that are only available on Windows. Stefan asks how to find good problems to practice. I think just filtering the Codeforces problem set by rating is what I'll usually do. Laconic asks how to think about how many states there will be while solving DP problems. I would to write out a state. I think it usually is most helpful to think about, like, what information do I need to maintain. So it might even be easier to think in terms of the transitions, where you think, in order to go from one state to the next, what information do I need? And that can help you figure out your state. And then from there, counting how many there are is usually pretty easy, because there might be, like, 2 dimensions and one goes up to n and one goes up to k, so there are n times k of them. Divyansh asks, do I use Notepad++ for anything other than explaining problems on stream? I'll sometimes use it for, like, for typing notes during contests. I have, like, scratch paper next to me that I'll use for handwritten notes, but sometimes I like to be able to, like, type out more or longer thoughts, and so, like, this is, like, some of the stuff I was thinking about for F, for example, or here, like, some notes I took for E. Yeah, or like just during my daily life, whenever I need to, like, note something down quickly, I'll sometimes type it in Notepad++. Rosvan asks, is there some place on CList where it's specified how their rating is calculated? Not that I'm aware of. I've looked for a little bit, and I haven't been able to find anything. I agree that's a good question, though. I also would be interested to know. Maybe I have to refactor this a little bit. That'll do. Laconic asks, how can I explain the game or how can I play the game which I'm playing? So I'll put a link in the description. I think I explained through how the game works and how to play a little earlier in the stream. So I'd suggest rewinding to review that if you haven't seen it. Christy asks, will you also explain F1 or F2? Yeah, I did. I did earlier in the stream. So feel free to just rewind back a little bit. Rosvine asks, do I watch anime? I do not. That was pretty fast. That was almost a 3-second one. Do I need to go to this from the other angle? There we go. This game killed my productivity during my last semester of college, by the way. I mean, it turned out fine, but there were many afternoons in which I should have been studying, but this seemed more fun. Oops, can't do that. Okay, hold on. Yeah, I will say that I think I mentioned this earlier, but the thing that I find really fun about this is that you get used to is that there are a lot of patterns that you can learn and just as you get used to them by playing more games, you can continue to improve and win a larger and larger fraction. And so an example is, so for one of these threes, I know the only way to go around the 3 is to make a little U shape like this. And I also know that for the square, that means I'm going for the square. That the square has to happen either when you're going into the 3 or out of the 3. You can't like do a U like this, for example, because the square has to be passed through directly. And so that tells us the square, we have to go either through it this way or through it this way. But we can't go through the square left to right because this edge is blocked by these 2 cycles. And so we know that we have to go through this edge up and down. And that was enough to tell, and that showed me that I have to get to this point before I go through the 3 loop and then do like this. And so that obviously is like a lot of logic to work through when you're getting started. But as you play a bunch of a bunch of rounds of this game, you get better and better at recognizing things like that, and so it becomes really satisfying. Solution Seeker asks how to navigate in game. You can just use the arrow keys on your keyboard. Shashidar asks, what is my typing speed? Well, we tested it a moment ago on stream, and on stream I got 126. On a good day, I've gotten around like 150 to 160 on typing tests, but that's usually under like a shorter test time and on the keyboard I'm most familiar with. Let's see. Saeem asks, can I solve a relatively easy problem and share my thought process? Sure, why not? Problem is, I've solved most. I guess I haven't done this div 3 problem. Let's do a div 3C. I think that'll be good. All right. So we have a computer game. We're trying to level them up to complete quests. We have n quests numbered 1 to n. Wait, hold on. I feel like I've seen this problem. Maybe I like read through this already. Yeah, okay, I guess I didn't submit it, but I think I've seen this problem already. Maybe I'll try and find one that I haven't seen before. Have I don't think I've looked through the early problems for this educational round. Maybe I have, actually. Okay, maybe I'll do this one. So we have a string S, and we can perform an operation where we delete a character from S, and that costs 1 coin, or we can swap any pair of characters for free. And we want to create a good string, where a good string means that it means that for each I from 1 to the length of t, si is not equal to ti. The empty string is always good. What's the minimum cost to make the string t good? So the first thing I would notice is that because swapping is free, we can rearrange the characters of t no matter how, or any way we want. So all that matters is the number of zeros and ones in t. And so now let's say that after we So let's say, so now, let's say that we, or so now if we have like a given number of zeros and ones, then if we perform k operations, we need t to be different at every position from s, or from the first n minus k positions of s. So let's say that s of 1 to n minus k has a zeros and b ones. That means t needs to have a zeros and b ones, or sorry, b zeros and a ones. All right. So if s initially has, or so s initially, let's say, has x zeros and y ones, and so we need to see if in k, or in k deletions, can we get b zeros and a ones. So in order to do this, we definitely need b to be less than or equal to x and a to be less than or equal to y. And since we only can perform k deletions, we need a plus b to equal x plus y minus k, which I guess should be automatically true because we know a plus b has to be n minus k and x plus y has to be equal to n. So I think these conditions should be sufficient. So that means I'm just going to iterate over k from 0 to n. And for each k, I'll maintain the values a and b and check if these conditions on x and y are satisfied. So I'll do this real quick. I'll parse the problem using my CLI. Okay, so read in a number of test cases. I might be reversing the names of my variables, but that's fine. All right, so now I'll iterate over the number of operations or over the next letter that we can delete. All right, so if after deleting I plus 1 to n, or let's see, yeah. So if, or maybe just to make it easier to read, I'll do it in a slightly more readable way. Although this might not be the way I would implement it if I was solving the problem on my own. But if after, or check it, we'll check if after I operations, our string is good. And we know that that just means b has to be less than or equal to x, a less than or equal to y. Then we'll print I. And if this never happens, if it takes all n operations, I'll output n. And then now we need to, and then now the the string that we're comparing to, we're looking at the last like n minus I characters of s. So we need to remove one character, or the back character of s. So if n minus I minus 1, which is the ith to last character of s, is a 1, then we'll decrease a, and otherwise we'll decrease b. Okay. So now I'll test it. Looks like doesn't work. Looks like I output too many lines, so I forgot to return after printing the answer. Simple mistake. And now looks like we get a C, so I'll copy the path and submit. Yeah, so if I was doing and so this obviously would have gone somewhat faster if I wasn't talking through and explaining my steps as I go, but that gives you a general idea of my process. And I think just for the sake of time, I'm probably not going to go like showcase any more problems. But if you want to see the process of me like solving some problems, I do have a bunch of screencasts available on my channel that you can watch if you're interested. Jerry or Stefan asked, how do I get to pupil on Codeforces? I guess I would say pretty much the same thing that well, I guess first of all, I'll link to a couple of blogs that I've linked already that are helpful for getting started, or are getting started, where I give some advice. So, and then, let's see. Yeah, and so other than that, I really think it's just about solving problems and learning from the ones that you don't solve, but I talked more about what that means earlier in the stream. Jerry asks, is there anything I do to improve productivity? I don't like follow any specific productivity techniques, if that's what you're asking. Rosman asks, do I use something like Obsidian or org mode for daily notes or tasks? No, I feel like, and I don't have enough like things that I want to keep organized that using one of those programs makes sense for me. Although I haven't heard what org mode is, so it looks like it's an Emacs thing. Shashank asks, why don't I show my typing speed now? I did a typing test a little bit earlier in the stream. And it says, I love watching you solve problems. Thanks, appreciate it. How do I test the test cases in terminal? Programming setup. So this is a command line interface that I haven't released to the public, mostly because I've done a lot of hacky things in the code that will make it only work on my system. I've linked the I've linked a video where I talk about what it does, or what my command line interface does, though, in the chat. And in that video, I also recommend some alternatives that are publicly available and are designed to work on machines that aren't mine. Rosvan asks, is my brother into competitive programming or math? He isn't super into competitive programming, although he sometimes does a little bit of leak code for fun. But he is into software engineering, and like he is planning to work as a software engineer after graduation. Laconic asks how to remember the patterns of the problems you solve in practice. I mean, I think so. Normally, like normally for me, I keep the patterns in my head as a lot of like if-then rules. So let's see, what's a good simple example? I mean, an example that I learned from F2 today is that like it's like if I want to test some geometric property in a graph, like for example, checking whether some object is contained inside another thing, then I should look at algorithms from plane geometry, like the point and polygon thing. And I think then once I notice an important feature of a problem, I can think about, okay, what is that telling me to do, or what does that suggest about the solution structure? Chandu asks, don't you get tired solving a lot of problems? No, it's fun for me. I do, but that said, I do like usually work in relatively short sessions. Like I can't get a little tired after doing a 5-hour ICPC practice contest, for example. Whoops. Can't do that. There we go. It's funny, I don't see the 4 diamonds arranged like that in a configuration that much. Okay, let's see. The other fun thing about this game is that once you do start to recognize a bunch of patterns, it really can make you feel like you have a sixth sense. Divyansha asks, do you play chess? No, I do not. Okay, how do I deal with... Okay, that's fine. I'm going to have to fix this at the end, but that's all right. Looks like my average time has gone down to 13.2 while I've been recording this. I guess the other thing that I should explain that's a little bit, that's not super obvious is the personal best is computed, whereas basically your best accuracy as the bottom of a 95%, I think it's 95% confidence interval. And so, for example, based on the fact that at one point I won 522 out of 537 games, and that means that the game is 95% confident that if my win probability had been constant over time, then my then my true win probability would be at least 95%, as an example. And the nice thing about this system is that even if you win your first game and you have like a 100% win rate, then the confidence interval will still have a pretty low bound, just because like winning what you could get lucky and win one game even if you only have like, say, a 10% win rate. Laconic asks, for the problems, I read the editorial for problems I can't solve, but when I come back to that problem, I'm not able to tackle it quickly. I would say then it would be good to focus on. So I think first of all, this isn't necessarily a failure situation. Like, it might be that the problem was much too hard for you, and so it's still like a little bit above your level. And so I wouldn't say it's important to memorize the solution to every problem you see. I think the most important thing is that you take like one key step away from reading the editorial, even if you don't internalize the entire problem. But I think I think the key is figuring out like, okay, what's the next step that I didn't come up with on my own? How could I have come up with that step on my own in the future? And then like you can, and then because I think then the step that like was the next one after the progress you made is the one that you're best equipped to think about, and that should at least help you improve some. Devion Shul asks, what game is this, and do you play any other stream games? I don't stream any other games. I mean, if there's demand for that, maybe I can, but I don't really see why watching someone who's really good at competitive programming play games that for the most part he's not especially good at is like going to be particularly appealing to my subscriber base. But anyway, I'll link this game in the chat. It's a lot of fun. I explained the rules a little bit earlier in the stream. Indie Gaming asks if I think AI will replace competitive programmers. No idea. I mean, we've seen that like certain AI models have been able to solve relatively easy programming contest problems, but there's a huge gap between the amount of thought it takes to solve, say, an 800 level problem versus a 3000 level problem, and I don't have any sense of whether it will eventually be able to solve the hardest programming contest problems, and if so, when. I think I need to go down here later somehow. Let's see, oh, maybe I can do this. Oh yeah, I think this is good. There we go, that was a tricky one. Eventually says, personally, I would prefer watching you explain solutions post-contest. Yeah, I imagine most people would. I would imagine that's what most of you are here for. I think I'm gonna need to come back in. No, I guess I've got to do these squares now. There we go. I had to do things in a little bit of a different order from what I initially envisioned. Nope, that's not going to work. This is a tricky one. Okay, I think this is the right order. There we go. Same as sometimes I feel like I can solve a problem, but it takes time. It takes 1.5 hours or more. That's fine. I mean, obviously, I think over time you'll get faster, but I wouldn't say like you should specifically focus on solving problems really quickly. I think if you can solve a problem, but it takes you 90 minutes, then that's exactly the right level of problem to challenge you and learn from. Divyanshil asks, what game would I play? Probably if I was to do gaming streams, I would play the finals right now. Been having a lot of fun with that, but and I move around from game to game a lot. And yeah, Devon Chill also asks, I think I've been pronouncing a Y in there for some reason. Devon Chill asks, do I have a Discord server? And I do not right now. Laconic asks, can I do screen recordings of every contest I do? I find that when I'm doing screencasts, I tend to perform somewhat worse than I do in general, just because partly just because when I'm doing a screen recording, I can only use one monitor so that you all can see it, and that gives me a little bit less space to view things. And also just for psychological reasons. And so because of that, for example, like I don't see myself ever doing screencasts of Div 1 contests. Maybe like Div 1 virtual contests, but hard to say. So yes, if I don't play anything, what do or when I'm not doing competitive programming, what other stuff am I doing? Working obviously is a big one, but sometimes I'll read, I'll talk to my friends, I'll browse the internet, that sort of thing. Watch there's some TV shows that I like. Pretty simple stuff. I'm sure I missed a bunch of other hobbies, but those come to mind. Who is better, Colin or me? I mean, I don't like using the word better, but I do have a higher Codeforces rating right now. No, I think I had it right the first time. Well, oh, this is it. Okay. There we go. Okay, this is an interesting setup. Just gotta go back and hit that diamond. There we go. And we're good. Ooh, that's satisfying. That was a fun one. Says he is about the LGM level lately. Yeah, I mean, I don't watch his streams, so I have no idea how good he is right now. But I mean, again, if I was in his position, I would just do contests. There's not really any reason to because of the way the Codeforces rating algorithm works. There's no incentive to if you think that you're better than your current rating level, then there's no reason to not participate in a contest. Because like even if you're trying to get LGM and you're currently like 2600, which is about where he is, I think. Then if you do, doing a 2700 or then doing a contest and performing at 2700 level will get you closer to LGM, even though like ultimately you're going to need to do better than 2700 performance in order to reach that point. And of course, not doing a contest doesn't mean that he like can't perform above his current rating. He might just be like choosing not to compete for some reason. But I will say, like, if I was like trying to make LGM again, then my first thought would be like, oh, I should be doing a lot of contests. Okay, I got it. I can do it like this. Devon Chillet says I'm pronouncing their name pretty accurately. Glad to hear it. I feel like, I don't know, I'm not always great with pronunciations, but I try. All right, this is a good one. We'll probably end the stream before too much longer. Devon Chillet says they want me to stream on Twitch. Is there any particular reason, like, do you prefer Twitch to YouTube? Oh, shoot, hold on, I need to finish this. I got distracted by chat. Okay, no, this isn't gonna work. I'm gonna have to go back and fix this. Shoot, okay, what I'm trying to do is not going to work. That's unfortunate. I might actually lose this because I got distracted. One moment. Oh, here we go. No. Shoot, wait, I'm actually going to lose this. Okay, how am I supposed to get through this thing? Rip, okay, that's unfortunate. Let's see. Okay. Ashish asks, will I continue to stream contests further? They are. I'll try, but my availability is limited since I work on the weekdays and often have other obligations on the weekends. Stefan asks, wouldn't it be great to have 1v1 mode in this game? Yeah, I mean, that would be fun. Ananya says they're training some of their friends for IOI. They have no math contest experience, and I don't know how to. I don't know how to efficiently train them, so I started training them following your experimental way. I wanted to know if there are any cases you pilot and how long it takes them to reach blue. I haven't. Let's see. I think like some people commented saying they were like starting to follow the plan, but I haven't. I haven't seen anyone who's like completed and reported results. Hence why why I consider it experimental. But I'd be happy to hear if you have any thoughts as you try it, and if you have any suggestions that I should add to the blog post to make the plan more effective. Apisha asks, have I ever been to Europe? No, but the company that I'm going to be working for starting this May has an office in London, and so I won't be working there. I'll be in New York full time, but I probably will visit London at some point as a result of that. And I guess also there's a chance that that the next ICPC World Finals could always be held in Europe, because they have to reschedule them because of the ongoing conflict. So it was going to happen in Egypt, but I would be surprised if they're able to do a World Finals in Egypt by the end of the year. And so when they reschedule it, I wouldn't be surprised if they move it. And so there's always the possibility that could end up being in Europe. So yeah, we will see. But anyway, hopefully I'll visit Europe at some point, and I'm guessing that it'll probably happen before too much longer. Okay, hold on, this isn't gonna work. This is a hard one. Okay, I have to go do this part at the end. Does this help at all? No. I have not dealt with this configuration before. Oh, shoot. Okay, I was just about to get it right at the end, but no luck. Apish asks, can we get a screencast of some contests from Central Park and NYC? Probably not. It seems like the internet connection would be an issue. I can't remember if I answered this question already, but someone asked if I'm familiar with the last few IZHO problems. Can't find them anywhere, and no, I'm not. And they also asked, do I ski? No, I am from Texas, so we don't really have skiing weather around here. She says I sound somewhat similar to Second Thread. It's a funny coincidence. I actually know Second Thread somewhat well from meeting him at a couple of in-person programming contests. Here, trying to see. I'm wondering if anyone's posted anything about the ICPC schedule. The context for ICPC, by the way, is that they were supposed to announce the new date for the joint 2022 and 2023 World Finals yesterday, and they did not do so. So yeah, we are waiting. But it's going to be interesting just because my teammates start work early next year and I start a new job in May, and so there's a pretty good chance that we won't be able to attend if the contest is in the first month of any of our jobs. And aside from that, if they say that they're going to do the contest, say in like April, and it's going to be in Egypt, then I'm not really going to be able to trust them on that, because given that we don't know that the war is going to be resolved by April, I think there's a good chance that it would just get rescheduled again. So I'm gonna be interested to see both like what they say and how credible it is, or whether they actually are able to, whether the plan that they propose is actually realistic. We shall see. I have to admit that I haven't been overly impressed with the organization of ICPC in the last few years. Although I will say I think they maybe should have announced it earlier, but I do think like rescheduling the World Finals this time was sort of unavoidable. There's no real way they could have predicted the war in advance. No, hold on, this isn't gonna work. The problem is there's not really any other point at which I can break off and go down. Can I? No. Okay, what if I do this and then now? Okay, I think this will work. Shoot, there's that one still. Eck. Man, 3 losses in quick succession. That's not good. Oh, I see. I can go through the square horizontally. Or wait, no, I think I already was. What was I doing different? I don't know. Maybe I was trying to go through it vertically. Ananya asks, how was my experience in DACA at World Finals 21? It was a pretty good experience. I mean, the unfortunate thing is that there wasn't really that much time for touristy stuff because we spent so much time listening to repetitive speeches by ICPC organizers. And so didn't get to see much of the city, and the traffic situation, of course, was really crazy. But yeah, it was fun. I liked the concert event that they put on. Contest unfortunately didn't go that great just because my team and I were pretty out of practice at the time, but not much we can do about that. I hope to do better at the next World Finals. I will say though, I felt like the contest itself ended up being organized pretty well. I had a good experience with all the volunteers I interacted with, and it seemed like the whole event was pretty well put together. So yeah, props to ICPC for that one. I think that a lot of like the logistical aspects of coordinating in-person events they don't do great at. And so an example is that when NAC in 2021 was moved online with less than a week of notice, I thought that was a really bad move. I think like they just should have either like rescheduled it to be way later or just admitted that the contest was going to be online earlier so people wouldn't buy plane tickets. But I will say in ICPC's defense that aside from all of the like boring speeches that we have to sit through, the in-person components of the ICPC events are usually pretty fun. Okay, this one and down here is going to be a problem. And I don't entirely know how to solve it. Oh, maybe I can do this. Oh yeah, this will work. Nice. Can I stream CSCS additional problem set? I think likely not, just because I don't have enough free time to really work through that in a systematic way. And some of the I've looked at some of the problems, and some of them just seem really annoying to solve. Like a friend was talking to me recently about, I think this might be the very last problem. Yeah, like a particularly nasty example is a friend was talking to me about this problem, and this problem seemed extremely unpleasant to solve. So yeah, likely not planning on working through it in the near future. Interesting. Oh, maybe I can do like this. What is the minimum time needed to get a medal in IOI or red in Codeforces? Depends a lot on your prior background, how hard you work, that sort of thing. Like I guess what I'll say is I've never really seen a useful answer to a question of the form like how long does it take to achieve X level of success. I mean, you can see how long it typically takes most people to get to a certain point just by like if you go to the IOI or IOI webpage, for example, and look up a bunch of people who got medals, you can see how long they've been on Codeforces, for example. But that doesn't tell you, how much natural talent they have or how much they've like practiced for math contests beforehand or anything like that. So it's hard to give a useful answer. And like an example is that like I took 4 years or so to get to Grandmaster on Codeforces, and I had 5 years of math contest practice beforehand. But I think it would be possible to do all of that much faster if you devote more time to training than I did, or if you like start when you have a little bit more maturity and problem solving experience than I did. Someone asked, do I believe in talent? Yeah, I mean, I don't have a strong opinion on how much of or how strong the effect of talent is on competitive programming. Or like, I think another type of question that people ask a lot, where it's basically impossible to give you a useful answer, is like, can anyone become X rank? Because like, there's no way to do an experiment where we like lock a person of average intelligence in a room and tell them like, hey, you've got the rest of your life to devote to becoming a Codeforces Grandmaster. Like, but I do think like it is true that people are talented at different things, and that there's like some element of natural skill where for some people the process of solving competitive programming problems is easier than for others. And at the same time, I don't think there's like a universal metric of talent in the sense that like, for example, I think like competitive programming probably comes more naturally to me than it does to most people. But on the other hand, I'm very bad at like a lot of spatial tasks, or I have no artistic talent or things like that. So I think I will say like I think different people are good at different things, and it is true that some people have more natural talent at competitive programming. Again, without taking a stance on whether you need to have a certain level of intelligence to perform at a certain level in programming contests. So you asked, is this game endless? Yes and no. Each individual round is up to a minute, but ultimately like you can play as many rounds as you want, and every level is just generated using the same randomization. It's not like they get harder over time, for example, and so you can like keep playing as many rounds as you'd like. Hold on, okay, this isn't gonna work. Do I? No, I can't go up at the beginning, so I think I have to do something like this. Maybe going to the left will give me more space to work with. Oh, I can just go through a square like this, and then I'll just restart now. I don't know why I did not consider the possibility of using the square horizontally. Oh, Anonymous says they performed at the concert as an indie musician. That's super cool. Yeah, I thought they did a really good job with that. I was just really impressed with the production value for a concert being performed for a programming contest. I mean, in general, it seemed like Bangladesh put a lot of effort into organizing the contest. I mean, you could see ICPC signs for miles around the venue, which was pretty cool. Navan Chilat says, do you consider making a Discord server? Yeah, I'll think about it. I know maybe if I like can see a more clear-cut reason to have one, but I will say that just with my schedule, it becomes difficult to keep up with responding to questions that people send me at random times, and so I think for my own sake, it's easier to. I mean, I could imagine having a Discord server for general discussion, but I think in terms of like, I basically don't want to give the impression that like people can use it as a place to ask me questions when, just in terms of my own schedule, the easiest way for me is just to make myself available to answer questions during my streams, and then maybe not to be totally responsive outside of that time. Saeem asks, how many combinations are there to generate all rounds in this game? I don't know. It'd be an interesting math problem, but a lot. I mean, the way the randomization code works is it basically generates a random path of length up around like 25-ish from the left to the right endpoint, and then for each and then once it has a path, it'll basically come up. It'll basically put like I think 7. Is that right? 1, 2, 3, 4, 5, 6. Yeah, 7 cycles, 7 either diamonds or squares, and 7 numbers nearby your path in a way that's like consistent with the path, and then that'll be your puzzle. And for some puzzles, there will be alternate solutions other than coming up with the path that the random number generator had in mind. But that's a generation procedure, and one could imagine that you could get a lot of different paths this way, because there are a bunch of different paths, and for each path, there's a lot of different ways to turn it into. Oh, I have to go. Okay. There's a lot of different ways to turn even each individual path into a game board. But the problem is that you will get overcounting because the same game board can correspond to multiple paths. So yeah, be actually a pretty interesting problem to think about. I don't think I would know how to solve it. Okay, so this region is going to be a problem. Maybe I need to go up here first. Yeah. That's a key aspect, I think, of getting better at playing this game, is that once you've practiced, you start to learn to recognize situations where you're just not going to be able to work your way out of them, and you've got to start over and try doing something different. Because otherwise it can be really easy to get stuck doing the same wrong path over and over again. Okay, hold on. How do I... Okay, I guess maybe I go back for that diamond. Yeah, this will work. If you are a new or average in competitive programming, you'll likely find new algorithms in a contest. How do I know where all the algorithms are? I don't think there's... I think the closest thing I would say to a comprehensive list is the Usico guide. And I'll link that here. But I also would say, like, you don't need to try and learn every algorithm. Like, there are, I think a famous example of this is Nick's Things I Don't Know blog post, where he lists, like, a bunch of algorithms that a bunch of people keep talking about that none of people, or that know, or that a bunch of people talk about that he hasn't learned, and I would say, like, I know very few of these. I think I know RMQ and O of N and O of 1, and I think I know the general idea of what a Lichow segment tree is, but I haven't ever like coded up or used it at any point. I know that matching in general graph is like in a general graph is an algorithm that exists, but I've never used it. Anyway, so the point is that it doesn't make sense to try to learn every algorithm that could possibly come up, and instead, when you do a contest, you can look for any algorithms that you would have needed to know to solve a problem within your rating range. And if you fail to solve a problem because you didn't know a certain algorithm, then at that point it makes sense to learn that algorithm. Ashish asks, or says, I think AtCoder contests are better than Codeforces contests because Codeforces involves the use of math a lot. I don't think I agree with that. I think that, well, okay, it depends on the contest, because if you're looking at the early problems in an AtCoder beginner contest, then I would say, oops, this is an upcoming contest. Then I would say, yeah, there generally is going to be a little bit less math, and I think the early problems on an AtCoder beginner contest are pretty beginner friendly relative to the early problems on, say, a Codeforces Div 2 round. So like this problem, for example, is just direct implementation for this problem. I mean, it's kind of math, but really it's just you just like write a loop. Let's see, this problem. This maybe like involves a bit of math, but nothing fancy. But anyway, once you get to like the late ABC level, as well as the, like this is clearly a math problem. Once you get to the AtCoder regular contest or AtCoder grand contest level, I would say the AtCoder will involve significantly more math than Codeforces, and in particular, like there are significantly more fancy math topics like generating functions, for example, that will come up really frequently. Same asks, how did I find this game? The guy who made it is on my Facebook friends list, and he posted it, and I gave it a try. Scarlett S says, good to see you, by the way. CP Algorithms is a good resource, and I'll link that again. I think I've linked it already. But some of the implementations are slow, and I agree with both those sentiments. Good resource, but you might need to change out the implementations because some of them won't be super fast. Okay, I think I have to go up here. Cool. Nice. Can I suggest some resources for dynamic programming? I think for that I'm going to direct you to, should be in gold, to the USICO Guide DP section, which has links to a bunch of different resources that you can use. So I could link you to any of these like individual resources, but each of these posts and these videos will be pretty useful. So, oh, and I guess the other thing I would say is that if you want just some practice problems to learn standard DP tricks, the AtCoder DP contest is a good source to work from. Okay, I can go hit that diamond later. This time it might be a problem, though. Yeah, I think maybe I can do this. Shoot, but then I can't get back to the square. Yeah, and I think then this diamond becomes... Oh, wait, hold on. I can hit the diamond on the way to the square. Oh, but I have to hit this one somehow. Ah, shit, I'm going to lose this one. Can we say prefix sums or suffix sum problems are DP problems? I mean, you can. I don't know how useful it is to categorize them that way. Actually, this is kind of a funny story. When I was doing USICO Silver, I had just read like the section in Competitive Programming 3 about DP, so I knew what DP was. But I hadn't spent that much time using graph algorithms, and so what I ended up doing for, I think there was a problem somewhere around here. So it would have been in like December 2016. Yeah, there were some problems down here that used BFS. And so what ended up happening was that I ended up doing BFS, but I thought of it as a DP where the states are the vertices and the transitions are the edges. So you really can think about just about anything as DP. I don't know if like categorizing everything as DP is helpful, because at some point you just if you just look at any problem and say this is a DP problem, that categorization isn't making it easier for you to think about or solve the problems. Omkar asks, I tried your WSL TTY setup but wasn't able to install it correctly. Can you do a more in-depth tutorial? I think it'd be hard for me to explain in much more detail, but if you have like if you can give a specific sense of like where it went wrong, then that might be, or then like there's a chance I might be able to help with that. But in general, I'm not a Linux expert or a WSL expert, and so because of that, I don't have a great sense of all the weird issues that can come up. She says, I don't know why top competitive programs are mostly trained in Russia or Ukraine. I'm actually not sure that's the case. I mean, I think there are a lot from Russia, for sure. But also, like, you see a lot from, there's some from Poland, you see a lot from China or Japan, and then, of course, tourists from Belarus. I do think in general, how good a country is at competitive programming has some correlation with to what degree or doing well at competitive programming leads to admissions to top universities. And so for example, my understanding is that in Russia and China, like a couple of the Olympiad participants get guaranteed admissions to some of the top universities, and that provides an incentive for high schoolers to train really hard. Other than that, though, I don't have a great sense of the different factors that affect or strength at competitive programming across different countries. So it says, how difficult do I think IOI problems are on the Codeforces rating system? I'm not familiar enough with the IOI problems to really say with a lot of accuracy, but I would say the hardest IOI problems could easily be around 3500 difficulty. Especially because like it's much harder to solve a problem in 2 hours than it is to solve a problem in a 5-hour contest. The easiest IOI problems, like something like IOI 2017 combo, I think it was 2017, maybe it was 2018. Yeah, 2018. IOI 2018 combo, for example, I think getting the full solution could just be 1900-ish, maybe even less. On a more typical year, the easy problem might be 21 to 2300, but then there's a pretty wide range. And we can see that empirically in that, because if you look at the IOI standings, even some of the really strong competitors who have like 3,400 Codeforces ratings often struggle to 8K. Like I think even this year, Cheng Xian, who was rank, I don't know where they are right. Maybe they dropped off. But at the time of the IOI, they were second on Codeforces. They had like a 3,700 rating, and I think that they did an 8K IOI just because it turns out IOI is really hard at the high levels. Yeah, I think this robot problem, no one got 100 points on. And that's even when you consider that the Chinese team was, I think it was either 4 LGMs or it was 3 LGMs and someone who was really close. So yeah, the hardest IOI problems are really hard. Nope, gotta go up here and so work that one wasn't too bad. Wonder if I should, yeah, I'll do this part first, and then I can just, yeah, that'll work. Okay. Cool, that wasn't too bad. to go down through this. Can I? No, I'm going to need to go back for that. 2. I think if I can get this 2, I'll be fine, but... Okay, so that gets the 2, but now I don't have... Okay, no, that works. There we go. Ashish asks, was I not able to solve F1 and F2 from today's contest? I solved F1, but I didn't implement it just because, since it's unrated for me, it didn't seem like it seemed more fun to just think about the hard version rather than just to go for subtasks. I had an idea for F2 that might have worked, although I think the complexity was worse than the intended solution, and it could have been a tight squeeze. So and so I didn't have the editorial idea for F2. Turned out that there was a clever little observation that I was missing for that one. I think I was at like 570 before. I think I've played like 100 of these since starting the stream. Okay, how am I gonna... Maybe I can go back and I can do the square as my last to end the path. Yeah, that'll work. One thing I would be interested to see is if it's possible to modify this game to generate paths that are harder in some sense, and I think harder is difficult to quantify, but it's harder because it's not clear whether having more of these symbols makes it more or less difficult. But I think there probably is room, or it probably is possible to modify the generator so that the solutions to the problems are harder to come up with. But I have no idea how one would do that. It would be interesting to see though, just because I've gotten fairly consistent at solving solving the current puzzles. Although it took a while though, because I was at like 40% win rate at the beginning. Ananya asks, am I into cubing? No, but my brother is. I should see. I don't know if he has these videos on his YouTube channel, but at one point he had a video of himself solving a bunch of Rubik's Cubes blindfolded. Let me see if this is uploaded. It's pretty cool. Maybe he hasn't uploaded it. That's too bad. A lot of times this is frustrating because there's just like one symbol that you can't deal with, and you have like the perfect solution that deals with everything else, but then it turns out that just to fix that one error, you need to do something totally different. Suyash asks, how can someone develop logic like you and get answers intuitively faster? So I have a longer discussion of this earlier, but I think the key is to work on a lot of problems, read the editorials for the ones you're not able to solve, and try and distill every editorial into like one key lesson that you can take away and then apply to future problems. So just thinking about things like what was the one step that I wasn't able to come up with, and how could I have come up with this idea on my own the next time. Giga Chat asks, have I mastered all topics on Alchemist? No, although I think I have mastered. I would need to check, but I think I have mastered all the ones that I recommend practicing in my blog post. I think that if I went on Alchemist today, I could probably master all of the topics except geometry without much difficulty. And I can't remember how hard the Alchemist geometry gets, but I might need to review a little bit in order to get through those topics because I haven't done geometry in a really long time. Okay, this diamond is really annoying. Oh, there we go, yeah. But I also did a lot of my practice from non-Alchemist resources, and I like guiding people to Alchemist now just because then I can just put everything in one place, and Alchemist is free, and some of the books I used weren't free, and so Alchemist is nice because even if you're even if your circumstances make it difficult to pay for the all of the ALPS books, you can anyone can practice from Alchemist as long as they have an internet connection. But I think it's also interchangeable with other practice resources, and while I was training, I used some of those other resources. Okay, I'll need to go back and deal with some of this stuff. That should do it. Okay, maybe I'll get up to 700 games on this computer, and then I think we'll call it a day. It's been a long stream. Can I talk to you in general on some social media? Usually I don't make myself available for conversations with people I don't know in real life outside of my streams, and the reason basically is that I get these requests like this fairly frequently, and I just don't have time to work with everyone, and so the easiest thing for me to do is the easiest way to help as many people as possible in a way that's fair to everyone is to make myself available for streams, and then when I'm streaming, I'll answer everyone's questions. And then when I'm not streaming, then that means I'm doing other things, in my life and don't have the capacity to answer questions right then. We'll be following you. Thanks for everything. No problem. Thanks for joining the streams. Okay. Too bad. I was hoping I would be able to show you all a 3-second time during this stream, which I can do very, very occasionally, but it takes a lot of luck, especially because there has to be both a solution where a really simple solution and one that I can see and type out immediately. Since to solve one of these in 3 seconds, you have to hit about like 8 keys per second, assuming that the path has length 25. So it's doable, but it's pretty difficult, and unfortunately, I don't think I'm going to be able to show it today. All right, that's 700. We're at 679 out of 700. I think we might be just under 700 or 97%. Oh, 97% exactly. Cool. Maybe get to 98 someday. And average time is now 13 seconds. Very cool. All right, so I think that'll do it for today's stream. Thanks to everyone who stuck around. I'm surprised that we still have 30 people after, wow, 2.5 hours. Yeah, so hopefully there will be more of these at some point. Maybe I'll do one on Monday, actually. Maybe I'll might not have time on Monday actually. Yeah, not sure if I'll have time on Monday, but hopefully before too much longer. So I will see you all then.